Hello everyone. Today we will be talking about fluorescence. Fluorescence is a property that refers to a higher energy type of light being absorbed and re-emitted by an object into lower energy light, and in doing so releasing a little bit of heat. Uh, so fluorescence might seem kind of exotic, but it's not relegated to just chemicals in a lab. Here is my current clamp meter, and if we turn it off and then zap it with my UV Beast flashlight, all of its yellow parts glow extremely brightly. Let's shine it a bit from a ways away to demonstrate that it's glowing quite brightly. And in fact, the plastic on my soldering reels glows a very nice blue color, like that one over there too. And this screwdriver also fluoresces the almost the exact same kind of yellow. And these wire cutters glow green, and all of this stuff, those dip switches in there. Oh my goodness, it looks monochrome over here, but those dip switches, let's just get it from a distance. Those dip switches are fluorescing red. Ah, the camera records all of this ultraviolet as a deep purplish color, but in reality, it's a lot more dull than you might expect. And I have to really hold it at a distance to make sure that you can see the color, and it's not just all this color. But a common misconception about fluorescence is that ultraviolet is the only type of light that will cause fluorescence, because visible light can also produce fluorescence. Uh, by the way, this is a rather large UV beast ultraviolet floodlight that just has a bunch of standard 395 ultraviolet diodes in there. Lovely. So here I need a high power blue light source. So here I have a, a NeoPixel LED strip that is hooked up to an Arduino, and when I plug it in, it drives it in a certain way so that it produces some strong blue light. Notice that the yellow highlights on my clamp meter are still glowing that nice yellow that you saw with the original, but aren't. Uh, this is not exactly the most reliable thing. It's just built on a standard breadboard, so this is not exactly top-notch quality, but it's refusing to restart. Okay, there we go. Yeah, it's still glowing quite a bright yellow, and the blue doesn't work because it's just blue to blue, so that's not going to happen. But same thing with this screwdriver over here. It's still glowing a nice vibrant yellow. The wire cutters, it's a little bit more dull. I don't think the light is energetic enough. I saw some of these dip switches. The plastic was fluorescing red, and indeed, it is fluorescing red. There is no red light in this setup, just blue light, and there's a couple other wavelengths too, but it's very dark in this room, so there's mostly blue light. And also, let's not forget about LED cobs. Hold your horses. Here is a cheap Harbor Freight flashlight that I modified to be rechargeable, and it has the exact kind of LED style I need. A big, long white LED with a big phosphor coating, which is often called an LED cob. If I hold it under the blue light, then notice that the cob appears to glow yellow. Well, you can't really see it in the overexposed camera, but in person I can tell that this little line, is glowing yellow. Just a bit too bright, and all the blue in the camera is overwhelming it. This is actually how white LEDs are made, or, well, how white light is made from LEDs, because LEDs can only be made to emit one specific wavelength, nothing else. So white light is a mixture of wavelengths. So how does that work? What it does is that there are a bunch of, you can't really see it over there, but you should be able to see that along the line there are a bunch of tiny dots, which are much more visible in person than on camera. Well, I guess you can see them. Uh, but each one of those white dots is a teeny tiny blue LED, and they're under the phosphor coating. So all of the light they're emitting goes to the phosphor coating, which is energized, basically the same concept as fluorescence, and re-emits its light over a broader range of spectrums, and that's how you get LED lights. So, for people who think that fluorescence is only caused by UV light, there that's just plain wrong. Blue LEDs, and in fact green LEDs too, to some extent, can also cause fluorescence. And in fact, if only ultraviolet light could have done fluorescence, then a lot of the work in making LED light bulbs would have been delayed, because you'd have to figure out how to make ultraviolet LEDs to energize the phosphor, which would be a lot harder back then. And blue LEDs were quite a bit earlier than ultraviolet LEDs, I believe. It was quite an adventure to make the blue LED in the first place, but going to ultraviolet must have been even tougher. Anyway, that's about it.